Why do some physicists swear by the S-UNC matrix while others insist on local fields, as if they're watching two different universes? In the energy filament theory, the S-UNC matrix is the far-field receipt, but local fields are the near-field C chart that tells you why the receipt looks that way. In standards talk, the S-UNC matrix is proudly coming only. You feed in an in state, you read out an out state, and you never have to narrate the messy middle. Local field theory does the opposite. It writes rules at every point in space and time, then tries to evolve the whole situation step by step, as if you had a live surveillance feed of reality. So one side feels like a clean before or after photo, and the other feels like a full construction log. The fight starts when people confuse what's convenient to calculate with what's physically real. Here's a simple analogy. A delivery receipt proves your package arrived, but it won't tell you whether it crossed a mountain pass, got delayed at customs, or took a detour because a bridge was closed. Route tracking does tell you that, but it can be noisy, over-detailed, and hard to summarize into a single number you can compare across shipments. The S-UNC matrix is the receipt. It's brilliant when you only care about the final accounting. But if your goal is to control the process, change the device, tune a boundary, open a channel, then the receipt alone is not enough, because you need the why that lives inside the trip. In this picture, the universe is in a sterile stage of abstract symbols. It's an energy sea with a living tension landscape, and interactions aren't dimensionless points but finite regions where the sea's texture gets carved and rewritten. Far away from that region, the details averaged out. So the receipt becomes natural. You can compress everything into what went in and what came out, and the middle is safely hidden behind a clean mapping. That's why the S-UNC matrix feels so powerful in scattering. It speaks the language of the far field, where only the durable totals survive. But near the action, the middle is the whole story. Fine textures matter, boundary modes matter. Channels can open, pinch, or reroute depending on whether local conditions cross thresholds. Sometimes a tension wall behaves like a breathing membrane, and a tiny geometric tweak decides whether two regions temporarily dock or stay separated. Think about near-field phenomena like tunneling-style handshakes. What looks like a miraculous shortcut in the final tally is often a narrow strip of allowed couplings that exists only because the local C chart briefly aligned. An S-matrix can tell you the probability that the shortcut shows up, but it won't tell you which microscopic handshake made it possible, or how to make it more likely without breaking everything else. A C chart can. You look for banded tension structures, micro-UNC pores-UNC-like connectivity, or a momentary channel alignment that lets the disturbance relay across the gap. This is the real reason the S-matrix versus field debate never dies. They are two projections of the same physical book, chosen at different zoom levels. At high energies and long distances, the receipt is the right language. In engineered quantum devices and boundary-sensitive setups, the root log becomes the right language, because the boundary is part of the mechanism, not a rounding error. The cleaning reconciliation is practical and honest. Use the S-UNC matrix when you need a verified delivery outcome, and use local fields when you need to understand, modify, and reliably reproduce the trip that creates that outcome. Next up, if the middle matters so much, what about the background itself? Why vacuum is not one universal nothing? Tap follow, share it on New Physics, Clear Universe.